So I was watching Evan and Katelyn on YouTube the other day, and they were reviewing a product that took DeWalt tool batteries and adapted it to work on a Dyson hand vacuum. They brought up some interesting points on the battery, but didn't understand why it existed as a product. They owned one of these vacuums, but it didn't have the issue that a lot of these earlier Dyson vacuums had. And they had an issue where the batteries were not good at all and could barely last more than 10 minutes, if that.
7 or 8 minutes max.
Yeah, ours goes 30.
I feel like something is wrong with his vacuum. I feel like it's clever to use an adapter for a common tool battery for your vacuum. I don't like that it adds weight to it, because one of the reasons I like a cordless vacuum is it's so lightweight.
Most people will use batteries like this.
Yeah, but the thing that I'm confused about, how is it dying after 7 or 8 minutes? I think something is just wrong, like it's not charging correctly or something.
We have a little battery estimator right here on the back of ours. It's like 50.
Yeah, 50 minutes. Are we gonna ruin our vacuum? I really like this vacuum.
I really like this vacuum.
Are we gonna fry it?
They brought up some interesting points, but what frustrated me was they wouldn't even try the battery in their vacuum due to fear of it destroying the vacuum. I was kind of surprised Evan, out of all people, was afraid to do this due to him actually being an engineer. I realize there's a lot of fear and uncertainty around batteries and a lot of misinformation by manufacturers that want to sell you a battery for way over the actual value of the battery itself. Or in the case of some companies, even trying to prevent the repair of your own device that you own. I want to clear some of this up. A battery is just a battery. And what is a battery? It's a chemical store of electrical energy. Most consumer rechargeable batteries and things are typically lithium-ion chemistry. The most important specs when looking at a battery are the voltage and the capacity of the battery. For those not familiar with electrical engineering, the best analogy I have is actually with water. So voltage is kind of like water pressure, whereas capacity is typically the amount of volume of water in gallons that a tank would carry. And to further the water analogy, amperage is like the amount of water you can flow through a pipe. So when adapting a battery that wasn't designed for something into something else, the main thing you want to look at is, does the voltage match the spec of the device you're connecting it to? You don't want to put 12 volts into a device that can only take 3. That's when you'll actually start to fry stuff. Most devices actually have a pretty wide voltage tolerance to them. Usually you can figure it out just by looking at the information on the device itself. Most devices have to list the voltage and watts the device, or power the device takes as an input. So for an example, if you had a tool battery that was 18 volts that you're putting in, say, a drill, and you wanted to last longer on a single charge, what you'd want to do is get a battery with the same voltage but a higher capacity. So instead of 3 amp hours, you would want to get a battery with maybe 6 amp hours or more. This would double the amount of battery life you would get out of a single charge. Another important thing to consider when adapting batteries into systems they don't necessarily belong in is polarity. So batteries have a anode and a cathode, or a positive and a negative, and some devices can actually take batteries with reverse polarity. They have circuit protections in there to handle that, but some don't. So you typically want to check that the polarity matches, that the positive goes to the positive and the negative goes to the negative. So that's more of a physical form factor type thing. There's typically going to be 2 main leads, a positive and a negative lead on the battery that are exposed, and you want to make sure those match whatever you're plugging it into. Sometimes the batteries are labeled with that polarity. In the case of some rechargeables, they're not, but you can actually figure this out very easily with a cheap multimeter. So you would just put, say if you have a battery that's under 20 volts, put your multimeter to max 20 volts DC, and you can probe it with the black and red leads on the battery and determine which end is positive and which end is negative. Just a note here, if you have the polarity flipped on these leads, the voltage will show up negative on the multimeter. And if you have an original battery from the device you're trying to adapt it to, you can verify the polarity on that matches. So what Evan and Katelyn could have done was check the battery using a multimeter to make sure the polarity matched up with the adapter and that the voltage was somewhat in the ballpark of the rated voltage of the vacuum itself. If those two things are the same, there would have been no risk at all of plugging that battery into the vacuum. One thing to note, typically batteries are labeled with their nominal voltage, which is kind of like the average operational voltage the system is designed for. Now, if you let the marketing department label the batteries, then you typically get the max voltage of the cell. So the difference between an 18 volt and most 20 volt tool batteries is nothing. There's usually a max of some sort labeled next to the voltage. So they're selling an 18 volt tool battery as a 20 volt when they're exactly the same. As you can see, this 18 volt battery is reading 19.4 volts. So it's actually a little undercharged, which you can verify by this one having an LED indicator. So this one's probably about 2/3 full. Usually these are around 20 volts maximum. And then for this 12 volt battery, we can check that the voltage matches as well. On these, you can see the labeled contacts are in the middle, and there's also these extra pins here in the middle contacts. There's 2. So we'll touch the middle ones. If I can make contact. And you can see there's just over 12 volts on this battery. So you're probably wondering, what are these extra little pins here? So if I connect my ground or negative lead to negative and I probe these other pins, you can see there's a voltage there that's not the actual cell or not the actual pack voltage, and that's because I believe these are for the different cells. So chargers can balance the voltage of each individual cell. You'll see that on these larger packs in the form of these like connectors. I think there's 7 pins there. So there's probably 7 different cells in this pack that the charger can use this to balance off of. Typically, the tools won't use these in any way. This is just for charging. There is another pin here that might be like midpoint in the pack to pull half the voltage, and that might be used by like maybe a multi-speed drill to pull less voltage in a lower setting or something like that. A lot of times that's also not even used. It's most tools and devices will just pull off the main leads. Another thing to consider, like you might see this 12 volt tool battery and go, well, my car runs at 12 volts, so shouldn't this be able to run my car? The voltage is the correct voltage, but you'll see the capacity is nowhere near the actual capacity of a car battery. I think they're more on the order of like 500 or 200 amp hours or something like that. And the more important thing to why you can't start a car with just one of these is the maximum current this battery can provide. It's not probably labeled on this battery. Yeah, I don't see a maximum amperage, but this is, from my experience, probably going to be in the realm of like 10 amps. max current draw, whereas a car battery, you're looking at 500, maybe 1,000 cold cranking amps to start over an electric motor. So these are not in the same classification of battery despite the voltage matching. So just be aware of that. Like there's limits to these. And there's also limits to this charging and maximum charge rates on these batteries as well. So that's something as well to keep in mind if you're doing something really out of the realm of normal with them. But for the car example, I do actually run my car off of a motorcycle battery and not a car battery, because the motorcycle battery I have is a lithium chemistry, whereas it originally came with a lead acid absorbed glass mat type battery. So the lithium battery, despite being smaller and lighter, actually can provide more cold cranking amps than that original lead acid battery could. It runs at approximately the same voltage, and the charge circuitry can handle charging off a car alternator or a motorcycle generator. So that's one case where you can actually change the battery that's in the vehicle. The thing to note with that was, because I went with an actual a smaller rated battery, even for capacity, is that the total rated capacity of that battery is still designed for a motorcycle and not a car load. So it does not have the same total capacity. The battery that my car originally came with, lead acid, typically have a much higher capacity rating too. So I wouldn't want to, say, leave my radio or lights on long term with the vehicle off, but it is more than enough to run the vehicle under normal operating conditions. On the subject of doing off-brand things with batteries, I was watching a video from James' channel the other day, and he hacked in a Dell laptop lithium-ion cell into a iPhone. The iPhone had a malfunctioning battery, and he wanted to check if replacing the battery would solve the issues that the phone was having before he went and shelled out money for an official replacement. The thing I saw after, though, was the Dell laptop cell actually functioned perfectly fine, and it was even showing capacity in the settings and some battery health stuff in the iPhone settings. But when he went to replace it with a third-party battery, like official battery replacement, the battery no longer had these functions anymore, and Apple was preventing it from working fully. This was despite that battery probably came with an actual official OEM Apple charge circuit, but Apple uses parts pairing, which is they basically put a serial number in the battery's charge controller circuit to match the phone. So if those don't match, the phone will either not work at all or will reduce the functionality of the system despite it having official parts in it. And you can see this in some cases where you can buy two brand new iPhones or other Apple devices and switch parts between them. They are official Apple parts for the same device, right? But then they won't work correctly because that parts pairing code doesn't match between the two phones. I think this is awful, and I think this falls under definitely some anti-rights to repair stuff. That probably deserves a rant on its own right. Louis Rossmann is a really good YouTuber to check out for stuff relating to right to repair and fighting for your ability to repair or keep all the device's functions after you've purchased them and own them. What I love is James realized a battery is just a battery, so he went back into the phone and desoldered the new battery charge controller and then soldered the original battery charge controller board onto the new cell, and it functioned perfectly fine. Thanks for listening to me rant into the void. I just wanted to clear up a few misconceptions with batteries that I see regularly on the internet. Thanks for watching, and have a great day.